In this part, we'll speak about conversion of units. I think you should be familiar with this concept. If not, you should do some practice. You can see some example in your textbook. So in some case, when units are not consistent, you may need to convert them to appropriate ones. Units can be treated like algebraic quantities that can cancel each other. So in this example, we have a car traveling at a speed of 38 meters per second. The question is the driver exceeding the speed limit of 75 miles per hour? First, we will convert meters to miles, knowing the relation between miles and meter. We know that one mile is 1,609 meters. And we will convert seconds to hour. So 1 hour is 60 times 60 seconds. So we will obtain as a final result after conversion 85 miles per hour. So this car is exceeding the speed limit at the highway. In this part, we'll speak about estimation and order of magnitude calculations. But first, I don't think it is any secret that if one were to do any kind of science, they are going to be dealing with a lot of numbers. It doesn't matter whether you do biology or chemistry or physics, numbers are involved. And in many cases, the numbers are very, very large or they are very, very small numbers. You could imagine some very large numbers. If we were to ask you how many atoms are there in the human body or the mass of Earth in kilograms, those are a very large numbers. If I were to ask you the mass of an electron, that would be a very, very small number. So if I have to write this on a piece of paper, or if I were to publish some paper on using such numbers, it would take me forever to write this. And even more, it is hard to tell if I forgot to write a zero or another number, or if I maybe wrote too many zeros in those numbers. So there is a problem here. Is there a better way to write this? Yes, of course. The point of here is to talk about an easier way to write those numbers. And the easier way to write this, we call it scientific notation. I will give you some simple how to write a number in scientific notation. So the number 0.0086 can be written as 8.6 times 10 to power minus 3. So 10 to power minus 3 is a way to write in the scientific notation. So the number 720 can be written as 7.2 times 10 to power 2. So when we are using scientific notation, we will use 10 to power m. M can be positive or negative values. In other case, we should do some approximation based on a number of assumptions. So we may need to modify our assumption if more precise results are needed. So each time you are using an order of magnitude, you should use the power of 10. So first, you should express the number in scientific notation with the multiplier of the power of 10 between 1 and 10 and a unit. If the multiplier is less than 3.16, we use the order of magnitude of the number is the power of 10 in the scientific notation. If the multiplier is greater than 3.1, the order of magnitude is 1 larger than the power of 10 in the scientific notation. So some examples will clarify what I am saying. So the number 8.6 times 10 negative 3. 8.6 is greater than 3.1. So when we are doing our approximation, we will use 10 negative 2. So we have an order of magnitude is 1 larger than the power of 10. So 10 negative 2 is larger than 10 negative 3. So we are written this approximation as 10 negative 2. the number 2.1 times 10 negative 3. 2.1 is less than 3.1. So when we are doing our approximation, we will write this as 10 negative 3. So we use the same exponent. So now 7.2 times 10 to power 2. 7.2 is greater than 3.1. So when we are doing our approximation, we will use the expression 10 to power 3 because 7.2 is greater than 3.1. So we are using one larger than the power of 10 in our scientific notation. Now we'll speak about significant figures. First, we'll speak about uncertainty in measurement. There is an uncertainty in every measurement. This uncertainty carries over through the calculation. So whenever you are doing an experiment, you will obtain some errors. So these errors may due to the apertures, the experimental, and or the number of measurement made. So we need a technique to account for this uncertainty. So we need a technique to estimate how are this uncertainty are transformed in our calculation. We will use rules for significant figures to approximate the uncertainty in results of calculation. What is a significant figure? A significant figure is one that is reliably known. We are sure of this number. You should know that zeros may or may not be significant. Those used to position the decimal point are not significant. To remove ambiguity, use scientific notation. So when you are calculating the significant figure, you should use scientific notation. In a measurement, the significant figures include the first estimate. Some example to clarify what is a significant figure. The number 0.0075 has two significant figures. So we should write this number in scientific notation. So we will write as 7.5 times 10 negative 3. So we have two figures, 7 and 5. So here we have two figures. We are sure of 75, 7.5. So we have two significant figures. The number 10.0 has three figures. Why we have three figures? Because we have to the right of the decimal point 0. We should account this number. So when you have a 0 to the right of a number, you can count them as a figure, as a significant figures. In some time, we have numbers that are ambiguous. For example, 1500 meters. So if we write this number as 1.5 times 10 to power 3, we have 1.5 only, and we have two figures. Or if we have written this number as 1.50, so we should account the 0. So we have three figures, and 1.500, so in this case we have four figures. Don't be afraid about the significant figure. You will be quickly familiar with them. Now we will speak about operation with significant figures for the multiplication or division. When multiplying or dividing several quantities, the number of significant figures in the final answer is the same as the number of significant figures in the quantity having the smallest number of significant figures. To clarify this sentence, I will use an example. So if we are multiplying 25.57, we have here four figures, times 2.45, three figures. The final answer should have only three figures. So the final answer 62.6. You should be stopped at 6. If you are using your calculator, you will obtain 62.6 with other numbers. So we limit our figures to the lowest figures and the multiplication. But in the case of addition or subtraction, the number of decimal places in the result should equal the smallest number of decimal places in any term in the sum or difference. For example, 135 centimeter plus 3.25 centimeter. So 135 centimeter, we don't have any value after the decimal point. So when we are doing the addition, we should stop before the decimal point. So we should write 138, not 138.25. The 135 centimeter limits your answer to the unit decimal value. In summary, operation with significant figures, multiplication or division, so the rule for addition and subtraction are different than the rule for multiplication and division. For adding and subtracting the number of decimal places is the important consideration. For multiplying, dividing, the number of significant figures is the important consideration.